Let's revisit solving an equation and its related inequalities graphically. You've done this a lot of times before in chapter 1 and chapter 2 and even before in section 3.3. So nothing is really changing except for the functions getting a little more complicated. So just like we did in the previous sections, the first thing we're going to do is solve the equation first. So we're going to pull out our TI and remind ourselves what we're typing in to the TI. So I have to write this down so I can go back and forth. I'll do that. So I'm going to pull up my TI. And I have my previous example there. So I'm going to go back to my function editor. And I'll clear out whatever I had written in earlier. And I should be looking at typing in x cubed. X cubed plus 7x squared minus 9x. Oops, be careful. I saw that. Minus 9x and minus 63. So we'll be finding our zeros, roots are x-intercepts. I'll try out my previous window, see what happens. I'm feeling pretty good about that. Sometimes leaving your previous window in there does save us some time. If you want to get a fuller idea, just so that you see, maybe I always like to see the rest of the graph. Kind of show you. I'll change the window a little bit, maybe make the y min a little smaller. Or widen it out. There we go. So you can see our polynomial clearly. So now the idea is to find the x-intercepts. And I think we solved this problem analytically already, so we do have an idea what the x-intercepts are, and you can kind of see that they look to be crossing at the same places. But let's be clear about this and just do the calculations. So just double checking, I will calculate the 0 for each of these. So we'll take our time on this. I'm finding my left bound. And my right bound, and pressing enter. So we do see -7 as one of the roots or solutions of the equation. Repeat the process. Again, calculating our 0. We've been using second trace a lot now, so now it's second nature. So left bound, move over to right bound, make it guess, press enter. We got our other solution, -3, consistent with what we did in example 1. Second trace one more time. We're going to find that 0 very end. So you got to kind of utilize the arrow. Or if you want to press the X value to get there faster, you can. Enter. Left bound, right bound, and guess. And we do have a +3. So now that you have your intercepts, or I should say your solutions to the equation, the way you would show your work is by copying this graph on to your paper. So you can draw it if you'd like, a nice sketch. I do have the ability, I think I can copy and paste this, so I will. So let's go back. Feel free to sketch it as much as you'd like. Let's go back and share the screen with you so you can kind of see what I'm doing. And we have our graph. I think I have to do it below because it won't graph on top. So we'll keep that there. So kind of just keeping this in the viewing screen. If we are trying to figure out where we're equal to 0, we just found our x-intercepts. So the solution to part A would be, I believe we said it was -7, -3, and +3. So we're good to go there. Now, don't have to do any more work except for interpret the graph. So if you remember, when we're trying to inspect the graph and solve these inequalities, we have to look at the inequality in comparison, left side comparison with 0. So less than or equal to 0, we would be looking for what values of x give us negative y values. In other case, we're looking for what values of x give us the graph below the x-axis. Question mark. Now, if you look at each of the regions, you can kind of see right away, everyone to the left, and maybe I'll label this on the graph, very useful. I should have done that earlier. Just making sure I have my boundary points or my solutions. Everyone to the left of -7, all those x values give you those negative y values. So that's part of the solution. So I'll describe that. So part B, we would be describing -∞ to -7. And we do have another region that also gives us negative y values. Our graph below the x-axis, we do have -3 to +3. And notice I'm using brackets because of the inequality symbol, less than or equal to. And now similarly, basically you're choosing the x regions or the values of x that you did not choose in part B. You want to double check this one more time. What are we asking ourselves? What values of x give us positive y values? Well, let's draw that word positive a little bit better. In other words, we're looking for above the x-axis. So we can see right away, it's the region we didn't address yet. We should have, for part C, we should have -7 to -3. And then we have another region, all the way out, union, 3 to infinity. So you have your solution to your equation and related inequalities. And just so that we can prove it to ourselves, let's just compare. Let's scroll back a little bit. I think we solved this analytically in example 1. And it looks like we have the same solutions. So pretty nice, huh? The other cool thing about the sign analysis method, just so that I can kind of see, if you guys want to look one more time, humor me. See how the direction of our graph is heading, where endpoint behavior is down then up, and we see kind of above and below the x-axis. This is what's happening in your sign analysis method. So just kind of a quick sketch of the graph. There is a bit of noise here, but if I can, you can kind of see that we end up having the same idea with the information given from regions of our sign analysis method also give us a clue of what our graph looks like. So just in case your calculator gets taken away or you run out of batteries, you do have techniques to help you understand what the graphs look like.